We call this function composition, when you're composing one function of another function, okay? Usually we write a function as f of x, right? So if you write f of g of x, you've replaced this one little x with g of x. You put g into the function f, okay? Another way of writing this problem, just so you know in case the notation comes up, is f composed, a little circle, of g of 2. Okay, that means put g into the function f. Okay, so that's like the technical details. All you have to do for this problem, figure out what g of 2 is. So find 2 on the x-axis, and then g of 2 is the y value. So when x is 2, the y value is 0. So this is equivalent to this, because we just found out that g of 2 is 0. So now to figure out the final answer, we just need to find 0 on the x-axis for f. So over here on the left graph, the y value is 5. So that's the end. Okay. And then if you're asked to create an algebraic new function, this is saying, again, g is being put into the function f because it's replacing x in that function notation. So I'm going to start copying down the function f, but when I get to the letter x, it's saying I'm replacing x with what g of x is. So we've got 2 over x plus 5, but don't forget this minus 5 over here. Okay? And that's it. We just should simplify it. Okay? We put the function g into f. And then if you simplify, look, 5 minus 5 in the numerator, that simplifies nicely. And then here's an algebraic trick if you got fractions on top of fractions. A fraction is a statement of division, so you're taking this number 1 and you're dividing it by 2 over x, right? So if you're going to do that, then you'd flip and multiply the second fraction. So that's just x over 2 for our final answer. So this is x over 2.